All right, let's go over problems 17 through 21. So 17 was asking about this grade point average, okay, with a mean for the population is 2.61 and that standard deviation 0.5. So that's why I have that here. We were not told if this was normally distributed, okay? So what that tells me is that I would not be able to do any computing with the population about individual students. I would not be able to say the probability that an individual that, or the proportion of students that have a GPA of this up to the other thing, unless I knew they were normally distributed. But once you take samples of size 100, then that drop down sampling distribution is the large enough samples to have a sampling distribution that is distributed approximately normally. So that is the same mean, but the standard deviation is 0.5 over the square root of 100. Now there were two X bars. We were wanting to go with the area in between 2.51 and 2.71. So see, look here, I have a z-score for the 2.51 and a z-score for the 2.71. And then I norm CDF'd between those two values. So 95.44% of students will have GPA between 2.5 average. Oh, hold on a second. I said that wrong. 95.44% of samples of size 100 will average between 2.51 and 2.71. It is not about individual students, but the averages of samples of size 100. Okay, here was our prototype, and we actually did know that for these tires that the distribution of the lifetimes of the tires is normally distributed. So since we are told that, then we could do math with the population. So we did this z-score. What proportion of tires are lasting less than 36,000 miles when they should last an average of 38,500? So then we get that area and we norm CDF, the lower area, from negative 99 to negative 1. So that's from negative 99 to negative 1. Okay. And so there we have that. But then we say, hey, 5 tires. What's the average at 5? I should have put 4 as this problem because I'm pretty sure we want the 4 average tires on your car. I don't know who's buying 5, but anyway. So we're getting the average miles on 5. So our sample is 5. And so that changes our standard deviation of 2,500 divided by the square root of 5. So that's why we get different numbers, because you're dividing by the square root of 5. So that's negative 2.24. So we norm CDF that lower portion. So only 1.25% chance that you'll get an average of 5 tires that last less than 36,000 miles. Okay. One tire, a one tire lasting this long, that's only one standard deviation below the mean. That's not that unusual. But an average of 5 tires at 36,000 or below is unusual. Okay, so keep that in mind as to what is happening. All right, and our numbers 20 and 21. So again, we're talking about now battery life. Okay, and so it's supposed to last an average of 50 months with a standard deviation of 6. So that's our population values. And because they told me that this brand is distributed approximately normally, then we could do normal model math about individual batteries, the population of individual batteries. So that's why we were wondering what's the probability that a battery lasts less than 48 months. So that's how I get my z-score, 48 minus 50 over 6, and then I norm CDF negative 99 to negative 0.33. So 37% of batteries are going to last less than 48 months. Yikesies. Okay, but what if we get an average of 36 batteries, a sample of 36 batteries, and I average them? I get an X bar of 36 samples that averages 48 or less. Well, that's going to be much harder to happen because, look, that standard deviation is not 6 anymore. It is 6 over the square root of 36. So that's 1. Therefore, that's 1. And so then I have a z-score of -2. So I'm going to norm CDF that area. So what I'm saying is very not unusual at all to find one battery with that life of 36 or less, but actually quite unusual. Well, it's actually right on the 2 standard deviations below for an average of 36 batteries to average 48 or less months. All right, so there's your going over of that. Then you are going to finish up this packet, numbers 22 through 26. Just have one last day of practice on all of those sampling distribution problems. All right, good luck to you.